This is my journey into the discovery of color, and I invite you to join me. Particles, atoms, and electrons create photons, which equal wavelengths of color. This is an electron racing around an atom. A collision with a moving particle excites the atom. This causes an electron to jump to a higher level. During the fall from high energy back to its original energy, it releases extra energy in the form of a packet of electromagnetic energy. This is called a photon. Photons have very specific characteristics. Their wavelength of color exactly matches the distance the electron falls. And this makes color, photons, being absorbed and reflected. Color travels in wavelengths, with electric and magnetic fields pointing at right angles to each other. Light waves behave in a similar manner to waves of water. This is a side view of light, water, and the chart. A frontal view and a three-quarter view, showing electric and magnetic fields. Now let's take a look at a few different types of spectrums. We have the continuous spectrum, emitting all wavelengths of light. This one is the most common to us. The emission spectrum is when atoms do not experience many collisions with particles and only a few photons are released. The absorption spectrum is the absence of light, when light is unlikely to be emitted in the same direction as the absorbed photon, giving rise to dark lines in the spectrum. This is known as spectral lines. Spectral lines is celestial fingerprinting. This is where I have begun to specialize my studies, considering we can only see 2.5% of light surrounding us. I entice you to study the vibration and energy of neighboring colors, how they are positioned next to each other, across, on top of each other. Study their shapes and patterns which they create. Notice their tints, tones, and shadows. All colors lying adjacent to each other, their energy levels creating enormous effects on each other and us. Light shown through a prism changes direction and frequency. This change in speed separates colors and creates dark absorption lines between colors. We already know that light is wave and particle-like. Let's take a closer look at its shapes and patterns through a red filter. This grid or dot-like structure often shows color surrounded by shadow or shadow surrounded by color. Spectral lines are continually visible depending on your position within the spectrum. I have taken imaginary spectrum lines and placed it on top of the color chart. The color charts have been designed according to horizontal and vertical wavelengths. The crest of a wavelength is the lightest or brightest, while the trough falls into shadows. Notice how in the spectrum light either surrounds shadow or shadow surrounds light. Light cannot live without shadow or shadow without light. Next time you look at a tree, cloud, or grass, half close your eyes and look for the darkest darks and the lightest lights, and you will see the pattern. Compare the colors that lie next to the darkest darks and the lightest lights, and it will help you to see the in-between.